Hello everyone. Now we are going to see an example of an application on the results that we have seen so far about integration. This is an example of the pseudo-immediate solution. Our intention is to calculate this integral here. This integral we want to try to solve, as we can clearly see, is a rational function, a polynomial above and a polynomial below. First things first, I am going to try to identify the different parts of the integral. Then I will be separating the x and the x raised to the power of 4 minus 2x squared plus 2 in the following way. As we have already stated before, what we are trying to identify are the parts of the so-called big function. In this case, we realize that the x is separated on the side so that it does not bother us. And on the other end of the expression, in the denominator, we have a 4-degree polynomial, which theoretically is difficult to handle, since we do not see primitives that have an exponent 4 below, at least for now. However, observing it carefully and doing some little tricks, as I like to call them, we realize that the denominator is actually x squared minus 1 squared plus 1. If you develop the denominator's expression in the same way, you can clearly see it too. What happens here though? Well, actually, if we decide to identify the x squared minus 1 as a certain function, then the integral that we have is the x that we have not touched, the one above, and below I would have the function of x squared plus 1. That already sounds familiar, doesn't it? That has a very similar look to the primitive, which could give us an arctangent. Well, in order for that to give us an arctangent, indeed, we need the derivative of f, and the derivative of f is 2x. However, in this case, we do not have 2x, we do not have 2x multiplying, but we do have 1x instead, and that single x alone is going to save us. Even though we need to have 2x, yet we only have 1x, we must take into account that numbers can be rearranged. To address this, I employ a small trick which happens to be a common integration technique, multiplying by 2 and dividing by 2. The number that is dividing, I leave it out of the integral, and the number that is multiplying, I put it in. This way, I have the 1 divided by 2 out, but inside I have the 2x that I was looking for. Therefore, I end up having exactly what I was looking for in the first place. I have the 1 divided by 2 out of the integral. However, inside I do have the derivative multiplying by the 1 divided by the function of x squared plus 1. The integral we have just obtained already is a pseudo-immediate arctangent, and therefore this would be 1 divided by 2 of the arctangent of the function. Taking into account the fact that the function was x squared minus 1, we can easily replace the x squared minus 1 again. The main takeaways from this specific example are the same ones as those from the examples we have seen so far. We have to analyze the function thoroughly and attempt to identify regularities. It is also important to acknowledge that a direct solution may not always be evident. In many cases, you will not immediately see how to solve it, requiring a bit of ingenuity in order to resolve the functions and identify what we are looking for. In the case of the pseudo-immediates, it is essential to find a function and its derivative that are being multiplied. If the derivative that needs to be multiplied is not, but is almost there, due to the absence of a constant, the constant can be added. This is what we can observe in today's example. And that is the whole lesson. Thank you.